அனைவருக்கும் வணக்கம். I am Dr. R. Sivakumar, Assistant Professor in the Department of Chemistry, J.J. College of Arts and Science, Pudukottai. Now I am going to discuss the basic concept and chemical bonding. Now we can see what is a chemical bond. The chemical bond is the force of attraction that binds the two atoms together. A chemical bond balances the force of attraction and the force of the repulsion at a particular distance. That is a chemical bond. Why the chemical bond is formed? Because any atoms or molecules to attain the octet state and minimize the energy and gain the more stable and decrease the reactivity. So these are all the factors to form the chemical bonds. So when two atoms comes to close each other, as a force of attraction and the repulsion force operates between the two them. The distance at which the attractive force overcomes the repulsion force is called the bond distance. So this is a bond distance, and so many types of the chemical bonds is there. So some of the which are given. What are the types of the bonds? That is one ionic bond, and the second one is the covalent bond, and coordinate bond, metallic bond, the hydrogen bonds, and van der Waals bonds. So let us see one by one. Now first we can see ionic or kernel bond. So the ionic bond is formed by the complete transfer of valence electrons from a metal to a non-metal. So this was first studied by the Kosel. Example for the ionic compounds. Best example is sodium chloride. So when sodium atoms combined with the chlorine, so they form the sodium salt, chloride salts. So in each the sodium atom, the valence electronic configurations, valence shell 2, 8 and 1. In the chlorine 2, 8 and 7. So when form the sodium chloride, each atoms to attain the octet states. For example, Na plus 2 and comma 8 by the loss of one electron in the valence shell, and then Cl minus chloride anions formed by the accepting electrons and to form the octet 288. So likewise the magnesium combined with oxygen to form the magnesium oxides, and aluminum combined with the nitrogen to form the aluminum nitrates. In the ionic bond, the number of electrons transferred is equal to the electrovalency. So maximum number of the electrons transferred by the metal to the non-metal is 3. For example, in the case of aluminum fluoride, aluminum metal transfers 3 electrons to the fluoride. During the electron transfer, the outermost orbital of a metal is destroyed because it releases the electron, and the remaining portion is called the core or kernel. So this is bond also called the kernel bond. So the nature of the bond is in the ionic bond is the electrostatics or the covalent force of attraction. So it is a non-directional bond. And what are the conditions for the formation of ionic bond? The process of the bond formations must be the exothermic. So when bond is formed, the energy is released. So the del H, the enthalpy is negative. Some of the important concepts for the formation of the ionic compound: metal must have the low ionization energy, so it readily releases the electrons, and non-metal must have the high electron affinity, so it readily to accept the electrons, and ion must have the high lattice energy, and the cation should be large with low electronegativity, and anion must be small with the high electronegativity. These are all the conditions for the formation of an ionic compound. So the formation of the ionic compound can be shown or calculated by the cycle, that is a Born-Haber cycle. It is also used to find the lattice energy of ionic compound, ionization energy, and electron affinity. For example, when M is a metal in this form of salt, it when it is supposed to the sublimations, metal is solid is converted into gas, and ionization process it loss electron, that is the formation of cation plus electron minus. When X2 of molecule of X2, that is a halogen, decompose to give the halogen atom in the form of gaseous state. When it accepts electron, that is electron affinity, it forms the anion X minus. So the cation and the anions combine in the crystal formation. The lattice energy minus U gives Mx solid. So the delta H formation of enthalpy formation, that is given by the S plus 1 by 2 dissociation and plus ionization, electron affinity, and minus lattice energy, where S is the heat of the sublimation and the D is the heat of the dissociation, and E is nothing but the electron gain enthalpy, and U is the lattice energy. For the formation of the ionic solid, energy must be released during its formation, so that H must be the negative. Now we can see what are the properties of the ionic compounds. So the ionic compounds is a very solid crystalline structure with have the definite geometry, because the strong force of attraction as a constitution arranged in a definite pattern. So and the ionic compounds are hard in nature, very hard, because of the electrostatic force of attraction between these ions. So hardness is directly proportional to the force of the attraction, and the hardness directly proportional charge on the ion and inversely proportional to the ionic radius. And ionic compounds have the high value of boiling and melting points and density. So the boiling and melting point is directly proportional to the electrostatic force of attractions. And ionic compound shows the isomorphism. Isomorphism is nothing but the same crystalline structure. For example, sodium fluoride and magnesium oxide have the isomorphism. And ionic compounds are conductors in the fused molten or aqueous state due to the presence of the free ions. In solid state is non-conductor, because there is no free of electrons present in it. And so the fast ionic reaction as activation energy is 0 for the ions. And ionic compounds do not show the space isomerism due to the non-directional nature of the ionic compounds. And another important point is the lattice energy, that is lattice energy is released during the formation of an ionic solid molecule from its constituent ions. And another bond is the covalent bond. The covalent bond is formed by the equal sharing of electrons between the two similar or different atoms. If atoms are the same or the electron activity is the same, the covalent bond between is a non-polar, because the atoms are same or electron activity are same. For example, X2 molecule, halon Cl2 molecule, O2 and N2 molecule. All the atoms in which same, so the electron activity is same, it's a non-polar. If an atoms are different or they have different values of electron activity, then the covalent bond is formed between them is a polar. For example, water, H2O molecule, in which the oxygen is more electronegative, so it creates a negatively partial negative charge and creates a positive charge on the hydrogen. So it creates a polar in nature, and a HCl or HBr likewise. And the number of electrons shared or covalent bonds present is called as a covalency. One atom can share maximum of the 3 atoms with the other atoms. Orbital concept of the covalent bond is introduced by the Hitler and London. According to this concept, the covalent bond is formed due to the half-filled atomic orbitals having the electrons with opposite spin to each other. Due to the overlapping, the potential energy of the systems decreases. The internuclear distance with the maximum overlapping and greater degrees of potential energy is known as the bond length. So another one is the energy considered as the covalent bond. How the covalent bond is formed? By the energy concepts. When two hydrogen atoms, likewise HA and HB, with respect to electrons EA and EB, approach each other, there is a force of attractive and repulsion force operating with it. In this picture, Ha hydrogen atom and Hb hydrogen atom, the electrons are present, a nucleus. There is a force of attraction between attractive force the two atoms and the repulsion force acting between the two atoms. The attractive forces between the Ha hydrogen of atom, A hydrogen atom, the electron of hydrogen atom, A atom, and hydrogen Hb and the electron of B atoms, and Hb and the electron of A atom, and Ha and Eb. The attractive force between these atoms, and the repulsion forces are also acting between electron of A and electron of B, and between the nucleus of Ha and Hb. Please observe that the attractive force are more than the repulsion force, which results in the decreased energy. So the potential energy of the system decreases. The minimum energy point corresponds to the critical distance between the nuclei. When the maximum lowering of energy takes place, the distance is called the bond length. For example, hydrogen molecule, HH bond length is 74 pm. Another concept is the properties of the covalent bond compounds. The covalent compounds mostly occur in the solid, gaseous states. The molecular weight of the compound is high, it occurs in the solid state also. And another concept is the like dissolved likes, that is the non-polar solute dissolved in the non-polar solvent. For example, CCl4 dissolves in organic solvent, and polar solute dissolves in polar solvent, that is alcohol and ammonia dissolved in water. So another one is the covalent compounds have a low boiling point and melting point than the ionic compounds. The boiling point and melting point direct proportional to the hydrogen bonding and direct proportional to the molecular weight. So the strength of the covalent compounds due to the hydrogen bonding, HF is greater than hydrogen iodide and HBr and HCl. The covalent compounds are the non-conductor due to the absence of the free electrons. And covalent bond is directional and so the space isomerism. When the cations and anion close to each other, the shape of an anion destroyed by the cation. This is also called polarization. Due to this, the covalent nature developed in the ionic molecule. So the polarization direct proportional to the covalent nature and inversely proportional to the ionic nature. Now we can see the very important topic, the Pajan's rule, that is a polarization or covalent nature in the ionic compounds, in which the charge on the cation, that is a polarization. Covalent nature or polarization power of the cation direct proportional to the charge on the cation. That is, greater the charge on the cation, greater will be its polarizing power and more will be the covalent nature. For example, SiCl, silicon tetrachloride aluminum and magnesium chloride. When it is charged Si4 plus Cl4 minus, so charge is greater 4 in the silicon, and so silicon tetrachloride is greater than the AlCl3 and MgCl2 and the NaCl. So size of the cation, when charge is same and anion is common, the covalent nature direct proportional to the smaller of the cation. So in which LiCl, NaCl, in which anion is same, but in the cation size will be different. So in this order, LiCl is maximum covalent least ionic from lithium to cesium. Cesium chloride maximum ionic and least covalent, in which the lithium is the smallest size and the cesium is larger size. So another is the size of the anion. When the charge are the same and the cation is common, the polarization covalent or covalent nature direct proportional to size of anion. Hence, larger anions are more polarized. For example, lithium fluoride, lithium chloride, and lithium fluoride, like iodide. Larger the size of the anion, easier will be its polarization. And another one is the cation with the 18 valence electron has more polarizing power than the cation with the 8 valence electron. For example, zinc oxide and is greater than magnesium oxide, in which zinc Zn2 plus ion it 18 valence electron, in which the magnesium 2 plus is 8 valence electron. So the polarization is greater for the zinc oxide. As the covalent nature increases, the intensity of color increases. Another bond is the coordinate or semipolar bond. It is formed by the donation of electron pair from the donor to a receiver atom. That is, it involves the partial transfer or unequal sharing of electrons. So it is denoted by the dotted lines, that is the arrow line, from the donor to receiver. Coordinate bond is intermediate bond, that is between the ionic and covalent bond, but more closely to the covalent bonds, in which, for example, A is a donor atom, that acts as a Lewis base, electron pair donor. B is a receiver, that is acts as a Lewis acid. To form the coordinate bond, A gives B. That is formation of NH3 and BF3 molecule. For example, NH3 in nitrogen atom have the pair of electron, in which the sp3 hybridization and pyramidal structure. A boron trifluoride electron deficient species, sp3 trigonal. And nitrogen atoms gives the pair of electron to form the NH3BF3 molecule is a tetrahedral shape. The properties of the coordinate compound are more close to covalent compounds. Thank you.